to our second part of our episode on the nature of science. This one I'm calling the scientific method. And if you remember, we left off at the point where we were talking about two objects falling at different rates. And the contrast between what Aristotle had said, that the heavier object would hit the ground before the lighter object. Just to clarify, it wasn't that it was a silly idea that Aristotle came up with, but his concept came from the idea of a feather, which I don't have a feather, but I have a piece of paper. And if we drop a feather, or a piece of paper in this case, and a book at the same time, you can see that the paper clearly takes longer to fall. This was sort of what Aristotle had written about in this concept. Galileo didn't believe that, because if you take this piece of paper and you take away some of the other forces acting on it, forces is something we may talk about later, but if I can take away what's called air resistance and create the same mass, this hasn't changed, and when I drop those objects, just a quick little experiment, you can see that they fall at the same time. So we can't fault Aristotle's, but the problem was with society at that time. When Aristotle did that 2,500 years ago approximately, that idea had been adopted afterwards. Now, he wrote that down, and the Greek philosophers were very well respected. Their information traveled throughout the world. And so most educated people believed what Aristotle had said, that a heavy object would hit the ground first. So now along comes Galileo, and as I said, he probably wasn't the first person to do this, but he was the first person to do something about it. I'm sure people were seeing objects falling down all over the place and doing things. It's 2,000 years. But for 2,000 years, it was written and it was in the books, and it was like, being on Wikipedia or something. Like this was fact. Everybody believed it. So if Galileo is going to challenge an idea, he has to come up with a really interesting way to do that. And that's the key to this, because what we did at the end of our video, the previous one, was what Galileo suggested. He said, don't believe me. Remember when I was talking about that and I said, set the book and the pen aside, and I said, don't believe me. How about you get some objects at home and you drop them and you see what happens? Well, that's easier said than done in a time when we didn't have the internet, and Galileo was an isolated person in the early 1600s. I think I said correction, by the way. I think I said 500 years ago for Galileo on the last video, but it was 400 years ago. It was the early 1600s. At that time, maybe 10% at various parts of the world, 10 to 20% of people were literate. In other words, they could read and write, and so this information was within a very small group of people. But Galileo realized he had to reach those educated people and change their idea. And the way to do that was not to tell them like we used to do, and up until that point, that's how people got a lot of information, but was to show them, right? And showing is so much more significant than telling. So he decided to set up an experiment that involved dropping objects. He's known, and whether this is true or not, but he's known for the myth, or maybe truth, of dropping cannonballs off of the Leaning Tower of Pisa in Italy and watching them hit the ground at the same time. He took cannonballs of different masses. No one really knows if that experiment is true, that he did that, but it sounds cool. So let's pretend, right, that he was dropping these cannonballs of different masses and watching them hit the ground at the same time. But the problem was quantifying that. In other words, putting a value on that instead of just what your eye sees. And he realizes that objects fall through the air too quickly. I mean, even when we did this, there's variables that we can't control. Did they get, the pen stick to my finger a little bit as I let go? The book is catching a little air because it's bigger. There's variables that we call them in science. There's things that are changing the outcome. So what he wanted to do was limit that, and also slow it down so that he could observe very carefully this movement of an object. And that's where he, again, was brilliant. And he designed an experiment where he just took a simple little ramp. So I've got a little device here that it's just a piece of trim. If you have, board, or this piece of trim has a nice little groove on it, so that's why I'm using it. And if I place that up on a slope, that's what we mean by a ramp, like a slope like that. And he took balls, and so I've got a golf ball right here that I'm going to take, and he rolled those balls, you can see, down what's called an inclined plane. You can change the angle of that. If that was moving too fast, I'll just take my book here, and I'll quickly set this up, make that angle much less. And now when I'm letting the object go, I could count 1 second, 2 seconds, 3 seconds, 4 seconds. I could use my timer on my phone or something to actually time that to see how quickly those are done. And so he set an experiment up like that. And in a few minutes, I'm going to give you a chance to try that yourself if you'd like. Again, we'll pause the video and you can try that. But for now, I want to explain how he set this up, because his idea was, I don't want you to believe me. I want you to try this and believe it for yourself. That simple statement, that change of mental attitude, is something that you and I take for granted. Because when I did that experiment last video, you wanted to drop the books. You wanted me to drop the books. Don't stand there, hold them, Mr. Kermer, drop them things. And so that's the exciting part about what Galileo did, is he challenged people and said, here's my problem. Objects of different masses falling to the ground. My hypothesis, his case, was they hit the ground at the same time. Remember, we had three hypotheses. The heavy one could go first, the second one, light one, could hit first, or the equal. His hypothesis was that they would be equal. And he set an experiment. He listed his materials. In science, we list our materials. These are the things I need, kind of like a recipe when you're cooking something. And then this is my method. These are the steps that I need to take. Step number 1, we're going to set up our ramp. Step number 2, the ramp's going to be at this angle. Step number 3, we're going, so on and so forth. And that's what we call the scientific method. We start with a problem, we have a hypothesis, we list all the materials, and then we write a method of what we are going to do. And then we take observations. And we record very carefully these observations, as Galileo did. Ramps, how far they were going, the time it took them to go, and in his time he had to use a pendulum and how many times it swung back and forth to time it. He didn't have a nice handy, timer on his phone like you and I would have. But we could do that, right? And measure different objects. So if you wanted to try this at home, I have just a ping pong ball, or sorry, a golf ball. You might have a ping pong ball. This is a squash ball. Various kinds of objects. When they roll nicely, it's easier. If they're both kind of smooth, a tennis ball compared to this, of course, the foam or the fur on the tennis ball is kind of going to slow it down a bit, and it may not give you an accurate result. But you can try a number of different, what we call in science, variables. In other words, I can keep my ramp at that particular level. Oops, sorry about that big noise. And keep that ramp at a particular slope, and then just roll different objects down from a specific distance, from a specific height, and then count how many seconds on my phone it takes to do that. And when you do that accurately, as Galileo did, hopefully you're going to find the same thing he did. It doesn't matter the mass of the object. They fall at a very similar rate. And in fact, it's mathematical, which is a beautiful thing, because now we get to bring in math, which everybody loves, get to bring in math into science. That's why they're so, overlapped, and put a formula for this. Now, I'm not going to get into that because that's for maybe later programs or for advanced things. We're trying to get general concepts. But the idea is that objects would fall at a common rate regardless of their mass. So I'm going to, again, pause the video, give you a chance to go and try that. Set it up if you'd like. Find some different balls that you have around the house. Even just a board that you can set out on the stairs and put it on different stairs. Lower level stair, higher level stairs, and see the variances there. You can, even if it's difficult, just roll them, let them go at the same time. And if you don't even have to time them, just to try that. Okay. So go away, do that, and we'll be right back. Oh, hello. I was just practicing my jumping while you were doing the experiment. So how did that go? Did it turn out as you expected? That it wouldn't have mattered the mass of the object. It's going to roll down your inclined plane at basically the same rate, give or take what your limitations of your experiment might have been. Well, you have found the same thing that Galileo found then. Now, what we would do if we were setting this up in an actual lab, if I was your teacher, if we would start with our problem, we would have come up with a hypothesis, and all three of those hypotheses would have been good answers for your teacher. They're all good ones. And then we would have listed the materials and all the things that we were going to do, and then we would make a record of our observations, maybe a chart with the numbers, the values that we came up with, types of seconds it took for everything to fall, whatever. Okay, and then we would then go to the last stage, which I didn't mention before, which would be a discussion, and that's sort of what we've been doing or doing now. But we'd formally write that up in what we would call a scientific method, right? And so this really opened a big door when Galileo put this out there, because other scientists and other, you know, members of the educated community around the world read his work and thought, I can do that. Tried it, found his results were valid, started investigating some of his other ideas. One of his big ones was, you know, that the Earth goes around the sun, you know, to try to verify that. And then also, it led to this scientific revolution over the next several hundred years, in which all sorts of people were saying, "Hey, this is a way to prove this idea, and here you go and try this experiment." And we start putting those experiments out into the world, and other people verify those experiments, and that's really critical to the way science works. Now it's really easy for us. We can go onto Wikipedia, we type something in, comes up with an idea, and if it's from a scientific source, then it's just a piece of information we can gather, but that information has come through this process of somebody maybe hundreds of years ago coming up with an idea, designing an experiment, listing that experiment out, other people totally redoing that experiment to prove that it is correct, and after time after time after time, it becomes part of the common knowledge, so that you and I don't have to go and do these kinds of experiments every single time we need to look something up, right? But we have to be cognizant of, aware of the fact that that's what's behind what we call scientific ideas, right? And that's what I mean when I talk about the nature of science. This is built into what we talk about with science. My next program, the part 3 of this, is sort of an advanced level, more for senior students or adults who are interested in learning more about this, more about how that's evolved into the idea of what we do in science now. It's a little bit different, with from basic ideas when you're trying to, you know, prove something that's more complex. So I'll talk a little about that in the next program. If that's not of interest to you, just, you know, skip on into some of the other programs.